Dear participants, welcome to the 7th International Symposium on Multidisciplinary Studies and Innovative Technologies. 8th presentation will be made in this session. Online presentation will be held on October 26 and 27. Physical presentation will be held at Radisson Blu Hotel on October 28. We can start the presentation. First presentation, dear Ramzi Kasım Muhammed.
Okay. Hello, how are you?
Thank you. You can start.
Must be doing sharing with screen or no?
You can share.
I don't know. Let me try. It is okay?
Yeah.
Good evening. My name is Ramzi Qasim Mohammed. My title, Enhance Smart Grid Efficiency, Modify AN LSTM approach for energy storage and distribution optimize. This is a presentation online. Introduction, structure of the electrical grid, smart grid, concept of the smart grid, artificial neural network, proposed method, simulated scenarios, research and discussion, and conclusion. This introduction. The smart grid represented paradigm or shift in energy management aiming to optimize energy storage and distribution while accommodating the growing demand for a renewable energy resource. We investigate the application of a modified artificial neural network with long short-term memory, ANN LSTM, and addressing the multifaceted challenge of the smart grid through reservoir experimentation and simulation. The ANN LSTM is evaluated in 4 device scenarios, including normally operation, fluctuating renewable energy peak demand and grid instability. The results shown case the model exceptional predictive accuracy, low mean square error MSE, and rapid response team output performance other measure. This in ideal include their 3 points. Is developed. Number 1 is developed to general information on distribution network, more practically intelligent distribution network. Number 2 focuses on artificial neural network. Number 3, it is developed to the presentation of the many type of voltage control and distribution network and result of the application of the voltage adjustment method on the IEEE 33 busbar test network. Finally, this ideal focus on end with general conclusion and some perspectives. Number 2, structure of the electrical grid. An electrical network is a set of tools intended to produce, transport, distribute electrical energy and monitor on the quality of this energy, in particular, continuity of service and quality of voltage. The architecture or design of the network is a key factor in insurance. This objective, the organization of transmission and distribution network is subdivided according to the voltage level as shown in the next figure. This is sample from structure of the electrical grid, structure of the electrical grid into different voltage level, the transmission and distribution network to which the large centralized production group are connected and the distribution network supply most consumer. Production. Large electrical energy production group are generally based on the large synchronized alternators driven by steam, gas, or hydraulic turbine. They are connected to the transmission network via step-up transformer. Transport. Transmission network ensure the transport of the electrical energy over large distance in order to minimize, among other things, joule losses on the line. This network are at very high voltage from 63 kilovolt to 400 kilovolt. Distribution network continuous constant, the most important architect of the electricity network, the insurance, the distribution of electrical energy at the local level. Their voltage is less than or equal to 50 kilovolt. They are made up of two types of network. The medium voltage network with voltage level of 10 kilovoltage and 30 kilovoltage connected to the transport network, and the low voltage network, low voltage LV, with a voltage of 0.4 kilovolt. Contribution, the production of the thermal, light, and machinery energy are the three classic use of the electrical energy. They are found among both residential and industrial consumer. 3. Smart grid. Through the issue of the renewable energy and the management of increasing peak in electricity consumption, the concept is now being extended to all energy network, gas, heat, water. Smart grid are capable of the integrating and coordinating the action of different user, consumer, and or producer in the order to minimize inefficient, sustainable, economical, and scale electricity supply. Smart grid can be defined as combination of an associated on past for intelligence transport, distribution, and contribution, intelligence, and communication. Therefore, from the producer to the final consumer, different model and architect can be found in the lecture or operating smart in the can be broken down into the level. This is number 5, artificial neural network. In this section, we be proved the overview of 3 fundamental artificial and are commonly used study involved collecting comprehensive data related to the smart grid, including historical energy consumption pattern, renewable condition and infrastructure, promising, remove, outline, handle missing quality, and normalize the data time series data we resemble to the insurance consistency and fabricated model. This is a proposed method. Number two, proposed method, where artificial neural network ANN model was initially constructed to serve as baseline. This ANN constant of multiple layers, including and an input layer, hidden layer, and an output layer. The activation connection number of neurons in each layer and hybrid parameter. B, modified ANN to enhance the model ability to manage energy storage, introduce modification. The key adaptation included. C, long short-term memory LSTM layer were integrated into the ANN architect to temporal dependent period, energy demand, and supply fluctuations. D, attenuation mechanism, and an attenuation mechanism was added to the prioritized futures effect. This is modified ANN with recurrent hidden layers. Number three, training and evaluation. A, data split. The proposed pre-processed data was split into training, validation, and test set. The training C was used for model parameter optimization, while the validation C was utilized for early stopping to prove overfitting. B, model training. Both the baseline ANN and the modified ANN were trained using back propagation and ADAM optimization. The RL component of the modified ANN was trained use the approximal policy optimization BB logarithm, BBO logarithm. C, evaluation metric. To assess the performance of the model, a set of evaluation metrics was employed, included mean absolute error, MEE, root, mean square error, RMSE, and R squared. Their metric were used to judge the of the model in predicting energy supply and demand. This is simulation number 7. This is simulation scenario. We have 4 scenario. Scenario number 1, normally operating condition. Scenario number 2, fluctuating renewable energy. Scenario number 3, peak energy demand. Scenario 4, grid instability. Result and discussion. For energy storage and distribution in smart grid scenario, we compare its performance to other model, discussion the mean square error, MSE, and examine response time in table 1. Provide an overview of the key parameter used in the ANN LSTM model. A, this point, A, comparison of the accuracy with other model. In table 2, we compare the accuracy of the ANN LSTM model with other commonly used model in neural network, CNN, decision tree, DT, and physiologic. This is 5 table. Table number 1, ANN LSTM parameter. Table 2, comprehensive of the model. Table 5, comprehensive. This is 5 tables. B, comprehensive of mean square error, MSE, the table of on the other model, providing an indication of the model productive performance. C, comprehensive of response time. In table 4, display the response time of the model which represented the time taken for each model of make periodication and desiccation in the simulated smart grid scenarios. D, comprehensive comprehension across scenario. In table 5, we provide comprehensive comparison of accuracy, response time, and MSE. 9, conclusion. Our findings demonstrate that the ANN LSTM model has been exceptional performance across adviers of said simulated scenario. Accuracy, predicted energy supply and demand dynamic in comparison to the other model, including support vector machine, SVM, convolution neural network, CNN, decision 3, DT, and physiologic. The ANN LSTM constantly outperforming in terms of accuracy, achieving an accuracy rated of 94.5% from 100 for first ROOM1. The model ex-husband of the lowest mean square error, MSE, and post a remarkable response time, making it is ideal choice for real-time application in the smart grid. And thank you for listening.
Thank you for presentation.
Thank you. It is my pleasure.
Next presentation, dear Ether.
Hi, Professor. How are you?
Thank you. You can start.
Okay. Okay, but let me share my screen.
Yeah.
Can you help me with that? Where can I share my screen from where? What shared now? Yeah, shared with me. Dear Professor, can you see my screen?
Yeah.
Okay. Hello, professors. My name is Athar Hossein Ali Al-Azzawi. I am a PhD student at Altenbash University in Istanbul. For today's presentation, we will talk about pseudobabble edema diagnosis based on a hybrid approach using deep transfer learning. In this work, we see in this screen the outlines we talk about it today. First of all, we will talk about the significance of our study and the aim of it. Then we will talk a general overview of our diseases. Then we will talk about the dataset we used, which is from Kaggle and is available for all. Then we will talk about the deep learning transfer technique that we used here to take our result. Finally, we'll take the result and the conclusion. Now, we will take a general view of significance of our study. First of all, our study aimed to improve the classification accuracy of the pseudobabble edema diagnosis using the MRI images using deep learning technique. The second aim of our work today is to assess the ability of the pre-trained model to classify our diseases, which is extremely advantageous because it can save time for developing a new model as well as to be a tool for health sector, which will help the doctors to saving time and to get a high result accuracy from manual process. In this slide, we can see our diseases, which is the babble edema, which is the most alarming result that can be discovered during a regular eye checkup. Even if the patient is not having an appearing symptoms, action might be required. Determining the actual babble edema from pseudobabble edema can be difficult, but checking the case of the patient with the patient who have absolutely no symptoms, we can take and be able to dealing with these difficult situations. Babble edema is an edema produced by increasing pressure inside the brain around the place where the optic nerve connects to the eye. If this place lifted with no treatment, this illness can lead to serious complications, such as abnormal optical changes or decreased sharpness of vision. And also it can lead to a permanent blindness. In this slide, we will talk about the dataset and description that we use in our work. The dataset used here, as I said before, it was on Kaggle, available for everyone. It was collected by Kim Eye Hospital with a total count of 1,396 images. Subdivided, as we see, 219 images for the pseudobabble edema, which is our diseases, and 295 for babble edema, and 779 for normal, which is the healthy one, or may be called control. In addition, the dataset was resized to a set with width 500 pixels with a fixed ratio of the aspect. Moreover, to obtain the fixed size input required by deep learning models or even machine learning models, each images can clipped with a size of 224 multiplied by 224 pixels at the optic nerve area. Then we use a pre-processing technique, which is segmentation. As we can see here, the resizing images picture and the segmentation. We segment images, which is a critical job in the medical image processing, where deep learning has made major advance in image segmentation. In addition, developing and training segmentation models for medical dataset is considered impossible owing to its costly and time-consuming nature of gathering and creating medical data, primarily because radiologists must be cautious in their intervention to these images. In this slide, I show the convolutional neural network method or technologies that we use in our approaches, which is ResNet 50 MobileNet, and ResNet 80 and GoogleNet, and these 4 convolutional neural network. These 4 well-known pre-trained CNN were employed in this work to discriminate between the pseudo-Babylonian edema and increased optic disc associated with optic nerves, which is as called GoogleNet and MobileNet and ResNet and the other one. This study was carried out in 4 stages. These stages are dataset and data segmentation and optimization and model evaluation. After we explained the segmentation phase and the model used for training phase, now we will talk about the optimization phase, which is the 3rd and 4th phase. The deep learning convolutional neural network model's performance was further investigated using optimizers. The optimizer was used to improve training accuracy while minimizing loss. The proposed research looked at the model's performance utilizing 3 optimizers, which is ADAM and RMS probe and the SGDM. The SGDM was used to accelerate gradient vector on the appropriate route for quicker configurations. Second, the RMS probe optimizer worked by averaging the separate learning rate for each weight, the magnitude of recent graduate for the weights. The last optimizer, which is the ADAM optimizer, relies on the matrices of the previous 2 approaches to provide a more optimized graded descent. All these optimizers, with the combination of the CNN method, give us an optimal result with the recent ResNet 50 using the ADAM optimizer. Moreover, we use the confusion matrix and we evaluate accuracy, sensitivity, and F1 score. The confusion matrix is a simplest concept for comparing the actual value with the predictive value and is a table of 4 values as shown in front of us to measure the performance of the classification model or classifier. Finally, we will talk about our 4 CNN results. As we see here, 4 tables, each of them consider the 3 evaluation matrices we evaluated in each CNN model: GoogleNet and ResNet and MobileNet and ResNet 50. As I said, the optimal score we got it from ResNet 15 with ADAM optimizer, which reached to 98%. But when we compared our result to some other studies, which is here, we see that we take over all the result here. Some of them use the same as our data, just like reference 27, the paper used same data with MobileNet and get the highest result, 96. But the 3 others used different data set, but also didn't get our result. So in conclusion, the ResNet 15 with ADAM optimization model architecture was the best performing transfer learning strategy, as I said, with 98% total accuracy. The proposed approach can assist doctors with their busy work schedules and early diagnosis. Third, the experimental findings demonstrate that the proposed model can reach the high performance obtained by employing the image processing method and transfer learning approaches utilized in earlier research using different methods. Finally, this research will aid in identification of pseudo-Babylodema and Babylodema automatically. Thank you for listening.
Thanks for presentation. Do you have any question? Okay. Thanks again. Next presentation, dear Zainab.
Hi, you hear me?
Hello. Yeah, you can start.
Okay. Can you share my screen? Show
Yeah.
my. Hi, everybody. My name is Zainab Dia, and my co-author, my supervisor, Dr. Ali Jan. My presentation title is Modify Active Learning Framework for Hyperspectral Image Classification with Convolutions Neural Network. Outline, introduction, methodology, experiment results, conclusion, and future work, and last this the end. Introduction, hyperspectral image. It is abbreviated. HSI is a powerful remote sensing technique, integrates spectral and contextual information for a wide range of applications, includes the dedication or recognition of agriculture targets and building targets in cities. The hyperspectral images are being employed more and more of each of these uses. HSI classification involves the unique labeling of pixel vector using specialized discriminant function that consider spectral and special feature extracted from the image. The collection of annotated data necessary for accurate model training is handled by virus elimination. To address this challenge, this research focuses on working with minimal number of samples while maintaining classification accuracy, especially when using deep learning techniques for HSI tasks. Active learning, it is abbreviated AL, emerges as a promising solution, strategically selecting samples of annotation and significantly reducing the required number of labeled samples. By implementing AL, we aim to streamline the annotation process, enhancing its efficiency and cost-effectiveness in the context of HSI classification, and operates under the assumption that not all samples are equally significant for classifier training. There are many studies in classification of HSI, including the combination of deep learning and active learning techniques. For example, stacks autoencoder, it is abbreviated SAE, are deep learning techniques is extracting special spectral characteristic. Local interaction were also analyzed by the 3D fully convolutional network, and also semi-supervised approach such as polynomial logistic with entropy, it is abbreviated EP, technique show high accuracy in classification of HSI. Later, the researchers combined the Markov random, MRF, and CNN feature, as well as active learning, deep learning, and smoothing level. Then finally, this Arthur Tasso, he suggests the CNN with AL and MRF model actively selecting sequential pixel, fine-tune CNN repeatedly, and employ MRF for improved classification. Methodology. To provide a better solution of the CNN AL-MRF method, our method proposed using dimensionality reduction method as a pre-processing step. It is not only enables the complexity and training step, but also provide higher classification performance compared to the original one. We use the principal component, it is abbreviated BCA, and average band, it is abbreviated AVG, which are the two main components of the pre-processing pipeline. The experiment was designed to compare the effectiveness as these two techniques improve the model's performance by focusing on the useful dimensional of data while removing least relevant. We aim to examine the effect dimensionality reduction and contribute to improve the classification efficiency by comparing the result of overall accuracy, average accuracy, and class-wise accuracies for BCA and AVG and execution times. The first technique we use is AVG, which simply reduces the dimensionality by average the sequential spectral band. The total number of spectral bands is decreased by computing the average value of the bands. The influence of a noisy or least discriminative band, which may be commonly in hyperspectral data, is particularly well mitigated by AVG. The second technique we use is applied BCA to a 3D data set to analyze and reduce dimension of data into a specific number of main components. BCA is a widely used method that aims to capture the most important variation in the data. BCA successfully reduces the dimensionality of data by converting the original spectral band into a new set of uncorrelated variables. The main advantage of this technique is that as much important information as possible is received and unnecessary or ineffective bands are removed. This figure is the modified of CNN ALMR, MLA and MRF method. First chooses an extremely low number of samples and do reduce dimensionality either using AVG or BCA. And next, data augmentation is applied by translating, rotation, flipping, and cropping. And then 8-layer CNN training face in the label set and all pixels in a label set are tested, and the most uncertain pixels are actively selected with the best versus second best strategy of AL. After labeling, these pixels are added to a label set, and the iteration continues until the number of iteration is completed. And finally, we use the MRF to improve the quality of the final product. Experiment result. To assess effectiveness of the proposed method, we ran several tests on the 3 benchmark dataset from around the world in the section. We implementation on a PC with a Nevada GeForce RTX 3060 graphics card and 64 gigabyte of memory. Our method is implemented in the MATLAB environment using MathConf net package. Sorry. The first dataset we use is Indiana bias dataset. Is captured by Averus on Indiana bias site in the northwest Indiana. Has 145 cross 145 pixel dataset, including 220 spectral reflectance band with wavelength between 0.4 and 2.5 meter. This dataset contains from 60 classes. Our method randomly selected 2% of the sample from each class and the training group. And the first round contains 300 ebooks, and our round of CNN contains 300 ebooks and 5 samples we are selected from the training set. The experiment results are reported in the table 2. If we look at the result, the dimension reduction effective gives high result. It gives high classification accuracy in the column of AVG, CNA, AL with MRF, but the faster method is BCA and CNN, ALM, MRF. The second dataset is a Bavia dataset. This dataset is widely used in hyperspectral remote sensing dataset for classification task and image analysis. They are collected from airborne hyperspectral sensor. This dataset contains from 9 classes as shown in table 3, and the dimension of this dataset are 610 pixels in width and 340 pixels in height and 103 spectral bands. It is therefore of 3D data cube. Also, we select 1% of the sample from each class, select actively 5 samples configured from a training set, and repeat this experiment 5 times. The table 4 display the experiment result in this table. Display the proposed method CNLM MRF and the processing pipeline that include dimensionality reduction like AVG and BCA. And in this table, the high accuracy was in AVG CNN, also in AVG CNN LMR, MRF, sorry, and the fast time execution in BCA CNN AL without MRF. 3 dataset is silence dataset. This dataset has a high spatial resolution, 3.7 meter pixel, and was captured by the 224 bands average sensor over the Silence Valley in California. It is have 270 samples and separated throughout 511 lines in the covered region. As many be apparent from table 5, Silence provide 60 virus classes, and also we select randomly 2% sample from each class, and 5 samples are actively selected from the training set. And this experiment show in the column table 6. Based on these outcomes, it is clear the CNA AL MRF method and dimensionally reduction technique like BCA and average band deliver the best result in the term of AA and OA. And in this table, the high accuracy or high result was in BCA, CNN, AL with MRF. So we can conclude the best result was in Indian bias. It has a high accuracy AVG. In AVG, CNN, AL, MRF was OA was 98.09 and AA is 96.25, sorry. And the computation time was also in Indiana Bynes in BCA, CNN, AL with MRF was 161.04. Finally, conclusion and future work. In our paper, which include active learning, convolution neural network, and Markov random field, furthermore, applying dimensionality reduction technique such as BCA and average provide a promising solution to reduce the burden data annotation while ensuring high classification accuracy. Comprehensive experimental results performed on the benchmark dataset Indiana Bynes University of Pavia and Silence demonstrate the power and efficiency of our approach and contribute significantly to improve the classification performance. Researchers in remote sensing and hyperspectral image analysis can easily adapt our methodology to specific characteristic and requirement of dataset, enabling more efficient and accurate classification of hyperspectral image. And last, thank you for listening.
Thank you for presentation.
Thank you
Do you
for
have any
you.
question? You're welcome. Next presentation, dear Ömer Favzi Avat. Dear Ömer. Okay. Dear Abdulwahid Karay.
Hi, Professor.
Hi. You can start.
Okay. Can you see?
Yeah.
Hi, everyone. Hand recognition solution is conference room intelligent lighting control technique. I am Abdul Wahid. In this study, conference room was illuminated with hand gestures. The lighting of an conference room is intended to be done controlled using MediaPipe in Python, and an artificial intelligence-based system have used to determine the quality of lighting in a closed area. The lighting system was built using the artificial intelligence-supported MediaPipe hand recognition solution, and image processing algorithms were used. As a result, it aimed to control the lighting control of a room or office with a solution that is applicable and impressive for everyone. Computer programs and models for hand pose recognition, lighting control will be investigated, and this will be done using a deep neural network solution called MediaPipe methodology. The hand tracing solution leverages a machine learning pipeline, which includes a model that operates on the cropped region supplied by the palm detector, delivering precise landmarks. The model's three outputs are illustrated in figure 1. Figure 1, you can see. The 21 hand landmark encompass X and Y and relative depth information. A hand flag is employed to signify the likelihood of a hand being present in the input image. It includes a binary classification indicating handedness, distinguishing between left or right hand. Hand landmark models. Commas were written according to the hand landmarks shown in figure 2. System description. Modeling. 3 different datasets were selected to train the MediaPipe models. The datasets include The wide dataset, focus internal collected dataset, and a synthetic dataset. 21 pieces of 3D quiz are output by hand QE models. The hand tag is used to know the probability of finding it, and the hand is used to know which hand is on the right or left. Light control will be done with my 3 main menu in hand gesture. With each hand movement, the main menus will be accessed. Entering the main menu, the intermediate menus menu will be processed. 3 main menus: number 1, illuminance level, 2, color temperature, and 3, microphone control. Smart lighting control system strategy, you can see. The hand decoration solution was applied to control the smart lighting system as part of the study's scope. This method can basically be expressed as the production of a control strategy that will turn on off the lighting system, increase the illuminance level by dimming it between 0% and 100%, and reduce the illuminance level by dimming it between 100 and 0%. Color change between our hand position and the colors on the color scale. I mean, we implement it to 270-degree hand rotation. Results. The project consisted of 4 phases. Creating a dataset for lighting using the created data in the MediaPark hand recognition solution. Defining the course corresponding to the meaning for each hand movement, making the software, and controlling the lighting. After creating datasets for lighting control for an office or hall, hand gesture recognition using MediaPark, defining what the gesture means and using them for lighting control by the program. Conclusion. In this study, we control the light of the office environment from the hand movements we defined. Each movement was made sense, and the lighting of the environment was controlled. As a result, the lighting control of a room office has been controlled with a solution that is feasible and impressive for everyone. Hand pose recognition has been successfully performed using computer programs and models for lighting control and a deep neural network solution called MediaPark. Accuracy evaluations of the branches commands with 100 repetitions are shown in figure, you can see. Future work. Studies we plan to do in the future: computer control applications for paralyzed and elderly patients to meet their daily needs. Thanks for listening.
Thank you for presentation. Do you have any question? Next presentation, dear Neslihan Ademi.
Hello.
Hello. You can start.
Can you see my screen?
Yeah.
Okay. The name of our study is, it's a case study, the effect of live sessions on student success in online education. I am Neslihan Ademi in the Computer Engineering Department of International Balkan University, which is in Skopje, North Macedonia. The study is a part of a bigger study which aims to develop an adaptive learning framework to be used in learning management systems. Learning management systems are so popular, especially after the rise of online education because of COVID structure. They allow to store data about all of the learners. This data can be explored, visualized, and analyzed to understand the trends in the learning behavior of the students. For this purpose, learning analytics and educational data mining is used so that we can obtain the trends in the behavior of the students, their learning habits, and we can find the factors affecting the success of the students. So this gained knowledge for the analysis can be used for the adaptation of new courses and learning contents. During the pandemic, actually, all universities, not only all education was online totally, but before that also at the State University here, the lectures were in blended form. So Moodle, a learning management system which is very popular and free, was used in normal education, formal education settings at the University of St. Cyril and Methodius, State University of Skopje. With the pandemic period, it was adopted to be used fully online. There were many servers occupied with this learning management system, so that it helped us a lot with the lectures. So the way that we teach, learn, and work changed a lot in that period. Big Blue Button is an open source web conferencing system. Before the pandemic, actually, it was not used. The courses were organized in a face-to-face manner. But with the pandemic, we introduced Big Blue Button, which is also a free and open source plugin for the model. And it was easy to integrate the model, except there were some physical difficulties, such as having extra servers for the support, for keeping the recording views, because we arranged that the professors could teach through the Big Blue Button, through Moodle system, and they could record their lectures. If there are any students, they could follow the lectures afterwards. The motivation of our study was to find out the following answers for the following questions. What is the effect of online session attendance to the course success in terms of points and grades? What is the effect of recording views on the course grades? And how the application of the badges affected the student success? Moodle offers a lot of reporting tools, but also it reports all actions which are done within the system by the tutors and by the students. So it is possible to follow what students are doing, what are their behaviors, but their logs provide raw data which cannot be easily seen, the trends and the behaviors of the students. So we analyze these logs to be able to obtain the reasons behind their success. As a methodology, it is a kind of observational log study. We both use partitioning by time and partitioning by user, so it is possible to analyze the logs according to time or based on the user. We applied several data mining steps. The first one was pre-processing. We downloaded log files. We cleaned the data first, and then all files belonging to each subject approximately contains 250,000 rows. We removed all unnecessary data related to instructor, administrator, system, And if there are some duplicate records, they were removed to cleanse the data by using R language and R Studio as a development environment. Also, we developed the scripts to automatize this analysis by using R language. A simple CSV file looks like this. Actually, it gives the time, certain day and time, the user, what kind of events were performed, event name, description of the event with details, and even the IP address where students or the tutors logged in. So it is not possible to see what's going on by just looking these logs. We transformed this data. We extracted the following attributes: user ID, visits, quizzes, assignments, forums, forum views, course views, file submissions, grade views, big blue button, and recording views. So after transforming this data, we have created new data frames, which we can analyze by using our scripts. We extracted online presence of the students for each week. Also, by using Pearson correlation coefficient, we found out correlations between course grade and activities which are performed in the learning management system, Moodle. And we compared our previous results with the new results. Previously, when we didn't have online live sessions, we had most important parameter, which is highly correlated on the course grade, was with 73% file submissions. Generally, these file submissions and assignment submissions are the same because all the submissions were in the form of assignments. So the success depended mostly on the assignments and the quizzes, and afterwards course views and the visits mostly. When we analyze with the new system, when the courses were fully online, actually these correlations have changed. Quizzes were with the correlation of 0.81 with the grade, so it was the most important, the highest correlation. Visits, total visit was 0.62, course views 0.55, and big blue button was the effect of big blue button, meaning that they attended online live session, was 0.54. When we see recording views, it was only 0.70. So we have seen that it was not so significant for the student success. When we compared big blue button attendance and quiz attendance, we have seen that when we compare both of them, they are almost similar. Big blue button attendance is 0.51 and quiz submissions are 0.5. So we can say that big blue button attendance was as important as quiz submissions in the system in terms of grades. When we analyzed, we have seen that every additional session attendance was associated with a 12.5 points increase in the course score in terms of points. When we have seen recording views, it was only 1.6 points increase in the course score. So we have seen that online participation to the live sessions was more important and more significant than viewing the recorded lectures. When we have seen the different settings in different academic years, for example, in the first 2 academic years, everything was blended. There were face-to-face learning, and Moodle was used only for distribution of materials, for online quizzes, for submitted homework, etc., the average grades were similar, 6.78, 6.79, and the percentage of passed students were differing. When online learning were introduced, at the beginning we didn't have big blue button introduced, firstly, because it was an emergency case, and it took time to arrange online sessions. In that case, we had an average of 7.41 for the grades, and percentage of passed students was 80%. When we introduced big blue button, we had online live sessions. The average grade increased to 8.48, meaning that students had opportunity to ask the questions immediately when they are stuck, and tutors helped them to understand better. And when we limited the activities in 2021 and 2022, we have seen that average grade was lower because we encouraged them to attend the live sessions more, and we limited the activities. For example, they could submit a quiz only once, and we didn't allow them to repeat some of the activities, so average grade was fallen to 7.32, but the percentage of the students who passed increased to 83% from the courses. Okay, as a conclusion, the presence of the students was more important, online presence, than in comparison to the recording periods for their course success. So online coaching actually helped them a lot to improve the learning process. When we analyze the failed students, it is found that their session attendance is quite low, and they were viewing the recordings of the live sessions, but we have seen that it didn't give the same effect. So, as a conclusion, the motivation for attending live sessions should be improved. Students with the best grade, when we analyze them, we have seen that they mostly attended big blue button sessions. Almost they didn't miss the sessions. And there were, of course, exceptions. For example, in one, only 50% of the best students didn't attend at the maximum level to these live sessions, but they still succeed to get the highest grade. So that we can say that each student has a unique behavior, but we can say that for the most of the students, saying 85%, they were very useful. When we applied the badges, the percentage of the passing students increased from 80% to 83%. As I mentioned at the beginning, this is just a small part of our big goal, developing a complete course framework, adaptive course framework, which can be applied in fully online education in computer engineering department. So our future direction of research will be analyzing other preferences of the students in terms of learning materials and assessment methods, because we gave them opportunity to select different assessment methods, not only quizzes, not only classical exams, but they can select assignments, they can do practical work, they can prepare projects within the courses. So actually ongoing study is going in that direction to obtain an overall adaptive learning framework. So my presentation was all. Thank you for your attention.
Thank you for presentation. Next presentation, dear Mehmet İlker Uygun.
Yes, I'm here. Can you see my screen? Yeah.
You can start.
Okay. Hello, everyone. I am Mehmet İlköğün, one of the team members of our study, which is EMG controlled bionic arm with machine learning. My department is mechatronics engineering, and we studied this work in Istanbul Bilgi University. Melisa Aleyna Çelikli, Berk Reçber, and our professor Yeşim Muniz are the other members. So let me start by giving an overview of our study. In an article published by a health organization in 2020, there are almost 60 million people with limb loss. And if you compare the rate, 40% lost either one or both arms. Limb loss comes with many problems. We know that there are many prosthetic arms on the market, and each of them is produced for the same purpose, which is to make those people's lives easier. But many can't afford these. Also, this situation causes psychological problems in some people. Although there are many prosthetics arms in market, many of them are not useful, durable, and cannot function. Considering these problems, we aim to develop a fully functional and affordable prosthetic arm that would offer these people a comfortable life. And let's take a quick look at the outline. Firstly, I will start with the literature, then explain the methods we used, then the results, and I will end these future works. Before I start, what is EMG? I would like to give a brief information. Electromyography measures response of electrical activity in muscles. There are two types of measurement methods. One of them is surface, and the other is intramuscular, which gives more accurate results. We used a surface EMG in the study for ethical reasons. There are many studies like ours in worldwide. These prosthetics arms in the figures are also designed for the same purpose, but they have fewer degrees of freedom because they have fewer servomotors and capabilities, which makes them not useful. Also, many do not last long. Coming to the methodology, what process did we follow in the design and software of this arm? To explain simply, the first step is data collection with EMG sensors placed on certain parts of the arm. Second step is classifying collected data with machine learning. And the last step is design of the bionic arm. Let's start with data acquisition. The first step to consider in data acquisition is where to place the electrodes. To understand this, we did many anatomical examinations, and we decided that the most appropriate positions to place the electrodes were on wrist and flexor carpi radialis. These electrodes help receive the positive and negative signals. Remaining electrodes have been placed on elbow for establishing a ground signal. Here in this picture, you can see the placement of electrodes on the right forearm. So, how did we collect data? When the electrodes properly placed, by using Python programming language, we recorded the signals of extension and flexion of movements for each finger and wrist on the EMG sensor. To explain it more clearly, let's take a ring finger as an example. The signals we initially received had insufficient amplitude for classification. We used ADS 1115 amplifier module to increase the amplitude of the signals. As seen in the finger on the right, the signal recorded from extension and flexion movement is approximately 10 times stronger. And there are approximately 50 readings in a second for a movement, and each movement has a unique character. To specifically define this movement, we have considered 20 of them. We increase the data range by taking this data not only from the resting state of the arm, but also from the fatigued arm. And we created a set of 50 moves for a finger to achieve accuracy and evaluate time. And we repeated this about 12 times, and that makes 600 moves for one finger. Before training the machine learning model, the recorded EMG signals undergo pre-processing. In this figure, you can see frequency filtering. After combining whole movements in a single set for the ring finger, the signal was sampled at 77 Hz for noise reduction. First, high-pass filter with a cutoff frequency of 20 Hz was applied. Then, low-pass filter with a cutoff frequency of 10 Hz was applied to remove noise and increase accuracy. Additionally, to make it easier to measure the amplitude of muscle contractions and to focus on the absolute value of signal, we convert the bipolar EMG signal into a unipolar signal. And lastly, using the feature extraction technique, quantifying the EMG signals in specific frequency bands helps us to train machine learning. Here you can see the design of the prosthetic arm, which was designed on SolidWorks, and it has a capacity of 24 degrees of freedom, including wrist. The fingers also have the ability of abduction and adduction, but there is no movement for them yet. So in our current study, there is 50 degrees of freedom with 50 servo motors, and we plan to take this mobility into consideration in the future works. And you can see the pictures of manufactured bionic hand and arm in figures. We plan to reduce the cost by using a 3D printer. Since PLA filament is both durable and light compared to other materials, the prototype in the study is the same size as a man's arm, and the total weight is around 810 grams, including the components. Also, steel pins and bearings are used to increase the flexibility and mobility, and its movement is carried out by flexible lines connected to fingers from servo motors. With these features, our prosthetic arm can easily lift up to 5 times its own weight. An entire circuit was established with an Arduino Uno and GRU EMG sensor. We used PCA 9675 model to drive all servo motors simultaneously. Also, it is designed to be easily charged, and it can carry out daily activities with rechargeable lithium-ion batteries. Overall, this work cost us approximately 10,000 liras, even though many prosthetic arms converted into products are sold for around 5,000 to 10,000 pounds in Europe. Coming to results, to test the parameter, we used grid source CV. After training the models, the prediction of the models were taken, and then by using the performance evaluation metrics F1 score, recall and precision, which are commonly used in Python, the accuracy of the model was calculated, and the results were pretty phenomenal. The accuracy of predicted value from random forest classifier and XGB classifier was around 89 to 90% comparing the real value. And overall, the result of our study showed how well EMG signal and machine learning could be combined for bionic arm control. In comparison to earlier literature, the bionic arm's motion control and functionality were greatly enhanced. For future works, we believe that using more channels will both increase accuracy and save time when collecting data. Additionally, using EMG and EEG sensors together will allow access to all the degrees of freedom for a hand. Also, electrodes wear out a lot when used, so a long-lasting and stable design can be developed by combining with Libre. Libre is a kind of testing for blood, instrument for blood. Also, by placing a touch sensor on the fingers, information can be transmitted to the user, whether the user has picked up an object or not. Thus, even blind people can use prosthetic arms. And the references, and thank you for the listening. Thank you for giving a chance to us. Any questions?
Hi, how are you? I have a question.
Yes,
First of all, great job. Thank you for this
Thank you.
presentation. Can we see slide 20?
20, okay. Alright.
Yeah.
So, yes.
What feature extraction you used? You didn't mention it.
I mean, we use feature extractions for training the machine learning. The last results coming from the feature extraction goes to training to machine learning.
That's right, but I'm asking the name of feature extraction you used.
Frequency domain, and there were one more thing, but I don't remember. One of them was the frequency domain, but the other one, I don't remember it.
It's okay, thank you.
Problem. Another question?
Thank you for presentation.
Thank you.
Dear Onur Karakaya.
Hi, can you hear me?
Yeah, you can start.
Okay, let me share my screen first. Can you see my slide?
Yeah.
Yes. Good day, everyone. I'm happy to be here to talk about our project called Classifying Anti-Cancer Peptides Using Gated Recurrent Units. My name is Onur Karakaya. I work as a senior software developer at Turkcell. I'm also studying for the master's degree in Information Systems Engineering at Kocaeli University. I want to express my thanks and respect to my advisor, Associate Professor Dr. Zeynep Hilal Kilimci, for her help, support, and contributions throughout our research. Let's get started. In the presentation, we discussed our workflow, research questions and hypotheses, literature review, methodology, proposed model, results, and references. We will explain it under these headings. Traditional cancer treatments, especially chemotherapy, while effective, often cause serious side effects and can damage healthy cells. Additionally, cancer cells may develop resistance to these methods, which may reduce the effectiveness and treatments. Anti-cancer peptides are short chains of amino acids that have demonstrated the ability to inhibit the growth of cancer cells. They are considering a promising avenue for developing more target and less harmful cancer treatments compared to traditional chemotherapy or radiation therapy. Research into these peptides continues to explore their potential as a novel approach to combating various types of cancers. In recent years, anti-cancer peptides have emerged as promising candidates in the field of cancer prevention and treatment. ACPs are known for their selective cancer cell selection, minimizing damage to healthy cells. However, manual classification of the increasing number of peptide sequences is time-consuming and depends on the use of large peptide libraries. This is where our research comes into play. We aim to speed up classification and make it more pricey with artificial intelligence. Our research addresses the critical importance of integrating artificial intelligence, especially deep learning, in the classification of anti-cancer peptides. Private studies found in the literature have shown that the limitation of conventional cancer treatments can be overcome. On the slides, you can see two sample studies with successful results and the accuracy values they achieved. Peptide-based therapies have attracted attention, but we need effective ways to identify anti-cancer peptides. Machine learning, especially deep learning, has been successful in variety of fields. We use deep learning models to classify anti-cancer peptides. You can see the table of anti-cancer and non-cancer peptide numbers in the datasets and the sample of the ANAC datasets in the slide. The reason we choose these datasets because it's so popular that we can compare it with the literature. The numbers of positive and negative data in the ANAC datasets are not homogeneous, so we preprocess those on the code site in order to randomly balance of data counts. In our study, we worked with 4 different datasets that are frequently used in the studies in the literature. This provides an advantage in making comparison with the other studies. We use the TF-IDF technique to convert peptides into digital vectors so they can be fed into deep learning models. Thus, we converted peptides in the string form to numerical data. Then we determined this vectorized data by giving it to 4 different models and analyzed their outputs. We aim to reach the most successful model. We introduced our GRU-based model for anti-cancer peptide classification. During our work, we used the ANAC plus A, ANAC plus B, and ACP datasets. We processed the data vectorized with the TF-IDF technique and SVM, MB, RNN, and GRU models. By comparing each model result with each other, we made changes to metrics of the parameters through our analyses. For the ANAC and ACP datasets, the most successful model among the models we developed with GRU model, while for the ANAC plus A and ANAC plus B datasets, we were able to observe that the most successful rates with the RNN model. We concentrated our work on the ACP datasets, where we achieved successful results compared to other studies in the literature. For the ANAC dataset, we didn't manage to beat the success rates in the other studies. In the image, you can see the flowchart of the experiments we conducted while determining the proposed model. This model demonstrates improved sensitivity in identifying anti-cancer peptides as demonstrated in our experiments. It's enabled us to obtain the most successful result among the studies conducted with ACP dataset in the literature. You can see the table and rock curve graph on the screen to compare the results with other studies conducted with ACP datasets. The rock curve visualizes the relationship between the sensitivity and specificity of the classification model. Although the success rates in the other studies were around 90%, while the maximum accuracy rate that could be achieved in the previous studies was 96.52%, but we achieved an accuracy value of 97.12% with our model in this study. Our experiment results are promising. The GRU model achieved high accuracy in classifying anti-cancer peptides. Our work shows the potential of deep learning in this field. We have consulted a variety of sources for this study. The datasets we use are open to use, and you can access them from the links in the slide. Additionally, from the studies we used comparisons, you can see the 2 of them in the slide too. If you have any question, I can answer. Thanks to all for your attention and interest in our work.
Hi, how are you?
Fine, thanks.
According to your work, you used SVM, right?
I couldn't get. Could you please repeat it?
You used SVM, right? Support vector machine?
Yeah.
Which kernel?
What?
Which kernel? SVM has several kernels, as you know, right?
SVM was not successful for our studies because SVM is not a deep learning model. It's a basic model, and we start to try to basic models at first, but then we get the results. We don't prefer to use with the SVM.
Thank you.
You're welcome.
Thank you for presentation.
Thank you.
Dear Enes Aykut.
Hello.
Hello.
Let me share my screen. My study about determining robot trajectory planning using image processing for wood painting. My professor is Zafer Bingöl. And this work funded in part by TÜBİTAK. Let me open laser. Here is most number. Our hits of presentation, introduction, literature review, suggested system, application, results, discussion, conclusion, and references. The study concentrates on industrial painting processes and the transformative impact of automation, highlighting the critical role of industrial painting in modern manufacturing and its impact on product quality, efficiency, and cost. The primary aim is to examine and design automation systems that enhance industrial painting processes, efficiency, and effectiveness. Exploring the potential advantages of automated painting systems for production line efficiency and product quality in the industry. Summary of related studies. First one is embedded systems and computer vision techniques utilized in spray painting robots, Shah et al. Focusing on various embedded systems and computer vision methodologies, techniques such as image processing, object detection, edge detection, and path localization are discussed in depth. Emphasis on reducing human interaction and improving work quality. Second one is using PaintNet, unstructured multipath learning from 3D point clouds for robotic spray painting. For robotic spray painting on arbitrary 3D surfaces, it uses 3D deep learning to estimate road sections. This one is third, embedded design of automatic pesticide spraying robot control system. It uses fuzzy PID variable spray control method in agriculture. The last one is distributed painting by a swarm of robots with unlimited sensing capabilities and its simulations. Algorithm for painting a rectangular region using a swarm of autonomous mobile robots. Robots are sorted according to their relative positions and the cells they will paint. Here is the software architecture for scanning parts and painting. In this study, a software was developed by incorporating several pre-existing functions and libraries along with various Python libraries. The development of the software adhered to the object-oriented programming paradigm to ensure a more organized, modular, and comprehensible programming structure. The time-of-flight camera serves as a fundamental tool for acquiring images by scanning parts on a conveyor, moving here on conveyor this part. These cameras can capture 2048x1 monochrome images triggered by the rising edge of the signals arriving at terminal on hit. Each pixel in the acquired image represents a height ranging in a 16-bit format. In scenarios where high sensitivity is paramount, the top camera can perform imaging with the assistance of a resolver. Contour and detection and hierarchy. Various Python libraries, including OpenCV functions, have been utilized to efficiently detect the contour and shape of scanned parts on a conveyor, which is a crucial step towards formulating a trajectory plan for the painting robot based on the identified features of wood parts. Upon acquiring the image of the conveyor parts, a binary image is generated, which is the fundamental for edge detection. For edge detection, counter detection, we will use this feature in OpenCV. The ATSUS thresholding method is employed due to its capability to autonomously determine the threshold value, adapting well to parts of varying heights positioned on the conveyor. Before establishing the inner-outer relationship of the contours, all contours must be identified. The return option in OpenCV's edge detection function presents all contours and their interrelationships, creating a comprehensive family hierarchy list as matrix. This hierarchy plays a pivotal role in making various feature inferences and serves as the linchpin of the software. Here is the hierarchical decision table for our software. Following counter detection and hierarchical categorization, the geometric shapes and object types of the scanned parts are ascertained. The software arranges the necessary mappings, pinpointing the best painting trajectory for each object, and sequences these trajectories for an overarching conveyor painting plan. Transitioning from pixel dimensions to millimeter dimensions is pivotal for flawless execution of the robot's movements. Notably, while images usually consider the top left point as the starting point, robots typically recognize center bottom points as the starting points. Such discrepancies necessitate transformations like rotation, scaling, and translation. The affine transformation is a broadly recognized model and frequently employed to perform the required 3D transformations. It facilitates changes in location, size, rotation, and shape. A series of basic transformations can be combined to create complex transformations, and these combinations are best defined in terms of matrix operations. Transformations in homogeneous coordinates can be expressed as matrix multiplications. Here is the affine transform matrix, and where is the rotation matrix? Here the R rotation matrix, and S is scaling matrix. T is the translation matrix. For robot simulation programs are used to determining the accessible area. It is our cabin and the object here and robot. We use here for simulation Robodeca. During the simulation, solid models such as the conveyor to which the robot is attached, the parts to be painted, and the cabin is resided in were incorporated into the program for real-time intricate operations. The kinematic equations used to determine the robot movements are provided below. T is transformation matrix. J is the Jacobian matrix. Here is the R is rotation matrix. D is translation vector. For transform, there is the here's workspace robot here, object is here, and this one is image plane. To demonstrate the transformation from the image plane to the real plane, combining the affine transformation matrix with the kinematic equations. In the robot software, the transformation can be expressed as follows that formula. Here is the first part of the equation represents the affine transformation, which relates the object coordinates to the spatial region for the robot frame. And the second part represents the kinematic transformation in the robot software, which facilitates the transition from the image plane to the real plane. Through this combined transformation equation, the robot is able to accurately interpret the object coordinates from the image data and execute precise movement in the real world to paint the object as required. Here's the suggested system set. The time of flight camera located at the entrance. Here is the laser scanner, aka time of flight. The frame rate of the top camera is dynamically adjusted to match the speed of the conveyor belt, ensuring that every image is captured at the optimal time. This synchronization is made possible by an external resolver connected to the conveyor roller. Here is the resolver. Each received frame is transmitted to the computer environment as a 2048x1 matrix, and the main image is obtained by adding these transmitted matrices one after another. The top camera receives data in monochrome and 16-bit per pixel format. Here is the object scanning in conveyor belt. Here is the scanned image. This resulting image is sent to the trajectory creation software, and the painting trajectory is created. The purpose of this trajectory is to ensure that the expenditure of energy, time, and material is minimal so that the part can be painted optimally. First, the edges and corners of scanned part are determined. When the specified contour points are sent to the trajectory software, it generates a trajectory for painting the outer edges and surface. Here is the blue lines are the edges of the scanned part. The robot movement here will be linear for painting edges. The pink dots are the locations where the paint head should rotate. Additionally, these pink dots are positioned to be the object in the most concise and understandable way. Since the scanned object piece is rectangular, it can be represented by a total of 4 pink dots, and 4 rotations of the paint head are required to paint the outer edges. The positions and orientations created the software for painting the outer edges are shown in table 2. The joint movements specified in the table do not involve spring paint, while the linear movements include painting the edges. Surface painting trajectory shown in figure. The software selected the ladder method painting method since the standard deviation in the scanned part image was below the specified threshold. Another determining factor is the distance between the nearest corners on the inner and outer contours is greater than quarter of shortest edge of the part. In summary, this study demonstrates that image processing techniques can be successfully used to create 3D painting trajectories. The utilization of image processing techniques has yielded numerous benefits, including improved accuracy and precision, faster execution, and reduced manual labor compared to traditional methods. By combining multiple techniques and adjusting the parameters appropriately, the best results can be achieved using these methods. I would like to show you a short video of system tests. Sorry. I think enough for one part. For as a discussion, this study demonstrates the effective development of a 3D painting pathway utilizing image processing techniques. Edge detection, thresholding, and filtering methods were instrumental in achieving accurate and precise painting paths. The adoption of image processing results in increased accuracy, speed, and reduced manual effort. The application of image processing in 3D painting is relatively new, necessitating further research to unlock its full potential. As a conclusion, the system employs a hierarchical edge detection algorithm for feature identification, aiding in trajectory planning using image processing and classification methods. The system software architecture leverages various Python libraries for data acquisition, image processing, and trajectory planning, ensuring robust performance. Experimental evaluations on objects such as MDF panels validate the system's effectiveness in extracting painting trajectories and planning based on detected features. In essence, the proposed system stands out as a comprehensive solution for automated painting in manufacturing, showcasing innovation in robotic trajectory planning and image processing for diverse industrial applications. Here is my references for this presentation. Thank you for listening.
Thank you for presentation. Do you have any question? Okay. All presentation all completed. Your certificates will be uploaded to paper management system. You can download it from there. Do you have any question about symposium? Okay. Thank you for contribution. See you in the next session.
Thank you.
See you.